This video will cover section 8.5, determinants and Cramer's rule. I'm going to just take a short time to read this paragraph if you want to just fast forward it and read it on your own from your handout. So as cyberspace absorbs more and more of the work, play, shopping, and socializing, where will it all end? Which activities will still be offline in 2025? Our technologically transformed lives can be traced back to the inventor Charles Babbage, who was alive from 1792 to 1871. Babbage knew of a method for solving linear systems called Cramer's rule. So that is what this section is all about, Cramer's rule. In honor of the Swiss geometer Gabriel Cramer, who was alive from 1704 to 1752. Cramer's rule was simple but involved numerous multiplications for large systems. Babbage, the inventor, designed a machine called the difference engine that consisted of tooted wheels of shafts for performing this multiplication. So here's a picture of that machine. Despite the fact that only 1/7 of the functions ever worked, Babbage's invention demonstrated how complex calculations could be handled mechanically. In 1944, scientists at IBM used the lessons of the difference engine to create the world's first computer. Those who invented computers hoped to relegate the drudgery of repeated computation to a machine. In this section, we look at a method for solving linear systems that play a critical role in this process. The method uses real numbers called determinants. So before we learn what Cramer's rule is all about, we will learn how to find determinants. Those determinants are associated with arrays of numbers, of course, matrices. As with matrix methods, solutions are obtained by writing down the coefficients and constants of a linear system and performing operations with them. So that is the end of the introduction. Let's go to the next slide. So let's go ahead and write down what a determinant is. And I want to tell you that a determinant is going to be just one single number. It's not going to be a matrix. So we're going to define it as a real number associated with every square matrix. And we have here the definition of the determinant of a 2 by 2 matrix. Finding the determinant of a 2 by 2 is fairly easy. So it is defined. Remember, this is a symbol for a matrix, the bracket, and the symbol for a determinant is just simply 2 vertical lines, like you can see here. So it is defined by the following. The determinant of the matrix with the entries A1, A2, B1, B2 is equal to the product of A1 times B2, so what you see here, minus the product of A2 times B1, what you see here. We also say that the value of the second order determinant is A1 times B2 minus A2 times B1. So now let's go ahead and evaluate the determinant of the following 2 by 2 matrices. And this process is fairly easy, so we're going to multiply the 2 numbers that are across the main diagonal. So 5 times 3 minus the numbers that are across the other diagonals. That would be 7 times 6. So this will be 15 minus 42, and so that will equal to negative 27. For the next problem, again, we multiply the numbers across the main diagonal. So 2 times negative 5, then we subtract the product of those two numbers. So that will be 4 times negative 3. With this, we will obtain negative 10 plus 12, and that will equal to 2.
Tell me.
Let's go to the next slide. So now, one of the rules on finding the determinant is to solve systems, of course. And so let's see how this will work. Now, consider the system that you guys see here. And we have, for the coefficients, we have A1, B1 for the first equation, A2, B2 for the second equation. The constant terms are C1 and C2. So what I'm going to do, so we're going to try to solve the system by elimination. And what I'm trying to do here is I'm trying to cancel the variable y. But if you notice, the coefficients are b sub 1 and b sub 2. So they are not the same coefficient and they're not opposites. So what I'm going to have to do here is I'm going to have to multiply, let me erase this for a minute. I'm going to have to multiply the first equation times b sub 2. Here we're assuming that a sub 1, a sub 2, b sub 1, b sub 2 are numbers. So we're going to multiply that by b sub 2, and we're going to multiply the second one by not only b sub 1, but negative b sub 1. And so the purpose of doing that is so that the coefficients of y will be opposites of each other, and that way we'll be able to cancel them. So by multiplying b sub 2 times the first term, we will obtain a sub 1 times b sub 2 times x. And then we do the same thing here. So we will obtain b sub 1, b sub 2 times y. And don't forget, we have to distribute that b sub 2 to the constant term. So in this case, we will have c sub 1, b sub 2. So we're done with the first equation. Now let's do the second one. So we have negative b sub 1 times a sub 2. And in this case, we will have negative a sub 2, b sub 1. And then we distribute that again, negative b sub 1 times b sub 2y. So we will have negative b sub 1, b sub 2, y. And then finally, we will have negative b sub 1 times c sub 2, and we will have negative c sub 2 times b sub 1. So now we have the same two equations, but multiplied by constants. Now, you can notice here why I chose to multiply by b sub 2 and negative b sub 1, so that we could have here opposite coefficients. And so that will allow me to cancel my variable y. Now, what I need to do next is to add my x's. And so this will look like this. We will have a sub 1, b sub 2, x minus a sub 2, b sub 1, x. And now I'm going to add my constant terms right here. And so that will be C sub 1, B sub 2 minus C sub 2, B sub 1. Now, what I'm going to do here, you notice both of these terms have an x. So I'm going to factor out that x. And by doing that, I will obtain A sub 1, B sub 2 minus A sub 2, B sub 1. On the right side, I still have my constant terms. And what I need to do next, just to solve for x, you notice that x is being multiplied by everything inside the parentheses here. So as you know, we're going to move it across. And once we do that, it's going to change to the inverse operation. And so that will be x is equal to C sub 1, B sub 2 minus C sub 2, B sub 1 divided by everything inside this parentheses here. So that will be A sub 1, B sub 2 minus A sub 2, B sub 1. So that is the idea behind using determinants to find systems, to find the solutions to systems of equations. Now, let's see how that works here. And we have here the idea of C sub 1 times B sub 2 minus C sub 2 times B1. And so that is actually the determinant of this matrix. Now, if we look at the denominator when we are solving for x, this one here, we see that same thing, the same product, and actually the difference of the products here. And so that one is actually the determinant listed here. So remember, determinant, you multiply those two, that's here, and then you subtract the product of those two numbers, and that's what we have listed here. Similarly, here, the determinant, you multiply those two quantities, and that's here, and then you subtract those two, and that's what we have here. Now, if you notice, all of that is actually being represented right here. So what we can say here is that x is going to be found by dividing the determinant of C1, C2, B1, B2. We're going to divide that by this determinant here. A1, A2, B1, B2. And so that right there, that is how we're going to find x. Now, to find y, I'm not going to go over the proof of that because I know you love proofs. So that one, just so you know, is right here. That is what I just proved to you. That's where the formula comes from. Now, you notice on the video, we have these terms here in red. So those terms, remember, C sub 1 and C sub 2 are actually the constant terms of the system, the ones that you see here. So what we're going to do is we're going to be making some substitutions. And so here we're going to find three determinants. One of them is just the determinant of the coefficients. So it's like if we use A sub 1, A sub 2, B sub 1, and B sub 2. That is the determinant. And remember, that is the product of A sub 1 times B sub 2 minus A sub 2 times B sub 1. So that is what I'm going to refer to as the determinant. Of the coefficients. Now, that would be one of them, but now we also, I know you notice here, d sub x and d sub y. So what happens there is that you use the same coefficients, but you replace the coefficients of x with the constant terms. And you do that when you are finding d sub x. So you replace the coefficients of x with the constant terms. So I will be referring to this as the determinant x. Now, the next one, which is the d sub y, that will be the same thing as the determinant of the coefficients, but instead of replacing the coefficients of x, you replace the coefficients of y. And you replace those, again, with the constant terms. And so I will be referring to that determinant as the determinant y. I will not call them dx and dy because once you take calculus, you will know why that is a term reserved for the derivative. One thing important to mention is that if the determinant of the coefficients is equal to 0, then the system has no solution. So that's why we're saying the determinant must not equal 0. A system with no solution will be an inconsistent system. We're talking about a 2 by 2 system. Graphically, it will be represented by 2 parallel lines. So if you encounter a determinant equaling to 0, that means that the system has no solution. All right, so let's go and practice a problem. So we have a system here, and we are being told to use Cramer's rule. On your take-home exam, you do have a problem like that, where you must use Cramer's rule. So please make sure you do use Cramer's rule and not another system. So the first thing we need to do here is, of course, create the coefficient matrix. And so that will be the matrix 5, 6, -4, and -5. So from there, we're going to get the determinant of the coefficient matrix. So that will be 5, 6, -4, and -5. Now to find the determinant, we multiply these terms. So it will be 5 times -5, and then we subtract the product of those terms. So that will be 6 times -4. This is equal to -25 plus 24. And so that equals to -1. So we're going to say that D, capital D, which we're using to represent the determinant of the system, will be -1. Now remember, we need to get 2 more determinants, and one of them will be the determinant of x, not dx, the determinant of x. So for that, we're going to use the same terms as the original determinant, but the difference is that we're going to substitute the coefficients for x with the constant terms. So that will be, instead of having 5 and 6, we will have 2 and 1. The numbers for the second column will remain the same. And then we find the determinant. So this will be the product of 2 times -5, that is -10. minus the product of 1 times negative 4, and so that is negative 4. This is equal to negative 10 plus 4, which is equal to negative 6. Now from there, we're going to move on, and now we're going to find the determinant of y. Not dy, determinant of y. So that will be the same as the coefficient matrix, but instead of changing the coefficients for x, we're going to change the coefficients for y with the constant terms. So instead of having negative 4 and negative 5, we're going to have a 2 and a 1. The coefficients for x will remain the same, 5 and 6. Now we find the determinant, and that will be 5 times 1 minus 6 times 2. And so that will be 5 minus 12, which is equal to negative 7. So we have here that the determinant of x is negative 6, the determinant of y is negative 7. And one thing I probably forgot to mention is that to find the solution for x, we will divide the determinant of x by the determinant of the coefficients. And to find y, we will divide the determinant of y divided by the determinant of the coefficients. So let's see. To find x, we need the determinant of x divided by the determinant. And so that will be negative 6, this number, divided by the determinant of the coefficients, which is negative 1. And this will equal to positive 6. Now to find y, we will divide the determinant of y divided by the determinant of the coefficients. Determinant of y is negative 7. We will divide it by the determinant of the coefficients, which is negative 1. And so that will give us positive 7. So this means that x is equal to 6 and y is equal to 7. And that is how you solve a system, 2 by 2 system, using Cramer's rule.